Welcome. Welcome to the course Computer Organization and Architecture. So this will be the first lecture. So the first topic we'll be discussing is the basic structure of a computer. And we'll be discussing this topic under these headings. First we'll be discussing the structure of a computer, which you might be familiar always, but again we'll be reinforcing that. And then we'll be discussing the certain machine instructions and their execution. Followed by that, we'll be discussing system software that enables the preparation and execution of programs. And we'll be discussing performance issues in a computer systems. Then we'll be discussing a brief history of computer development. So this is the flow of the first chapter. So in today's session, just we'll be discussing the structure of a computer. Okay, fine. So let us first try to understand the different types of computers. So before that, let us formally define a computer. How can we define a digital computer? So this is one of the way to define a digital computer. A digital computer is a fast electronic calculating machine that accepts digitized input, it processes it, and it produces the resulting output information. So a digital computer is a fast electronic calculating machine that accepts digitized input. So basically it receives digitized input. Digitized means what? Digitized means it accepts input in the form of zeros and ones. That is either there is a voltage or there is no voltage. Either it is on or it is off. So that is what we call it as digitized input. So or we call it as binary input. Okay. So this so the computer receives input in a digitized form, it processes it, and it produces the resulting output. So this is what a typical digital computer does. And we have different types of digital computers, and these types they generally vary in terms of size, cost, computational power, and the purpose of usage. So why should we have different types of computers? We have different types of computers because they vary in their size. The different computers and the different types of the computers will vary in the size, cost, its computational power, and its normal usage. Okay, fine. So the first type of computer is the personal computers or the desktop computers, which we use in our day-to-day life, which has a CPU box, and inside the CPU box there will be the processor which is connected to the motherboard, and inside that there will be hard disks. Okay, and you will be having a keyboard, and you will be having a monitor, and you'll be having a mouse. So this is a typical personal computer or a desktop computer which everybody uses in the home or office or in any normal day-to-day working environment. Such computers are called as personal computers or desktop computers. The next is notebook computers. So notebook computers also, these are computers which are very much similar to personal computers and desktop computers, but only thing is these are portable. That see, the personal computers or desktop computers are not portable. It is not that easy to carry the desktop. Okay, you won't feel that comfortable to carry the desktop from one place to another place. For example, if you are daily coming to college, you won't carry the desktop from your home to college and again back from college to home. Nobody will do that because that is a tedious job, right? But that is not the case with the notebook computers. The notebook computers has the similar capability as that of a personal computer or a desktop computer, but they are portable. That is, you can easily carry it from one place to another place. You can move it from home to office. You can daily carry it. So these are typical laptops which you can carry uh, wherever you go. Okay, so such computers are called as notebook computers. And then workstations. So workstations are also similar to personal computers, but they are high capable systems. These are high capable system, typically which is used to perform high resolution graphics applications, or to perform, or 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 these workstations may have higher degree of IO capability, and normally these are used for uh, engineering applications which demands a greater extent of computational power and graphic capacity. Such systems are called as workstations. And then we have enterprise systems or servers or mainframe computers, which is typically used in industries for business data processing. So it may be used in big companies like IBM or Oracle for processing huge amount of data. And in the last level, we have supercomputers. These are very big computers which may occupy a big room. And these computers were used for large scale numerical calculations. You want to perform numerical operations on very big number. Say the number itself, it contains 50 digits or 100 digits. On that number, you want to perform complex numerical operations. That can be done by a supercomputer. Okay? And normally supercomputers were used for applications like weather forecasting, aircraft design and simulation. And these tasks really they use huge amount of data which cannot be processed by a normal desktop or a workstation. Okay. So such computers are called as supercomputers. So these are the different types of computers which we can broadly classify, right? So what we have discussed is personal computer or desktop computers, then notebook, workstations, enterprise systems, servers or mainframes, and then supercomputers. Right? Then let us move to the functional units of a computer. So what are the functional units of a computer? So these are the typical functional units of a computer. A computer will have a IO module, that is input output module. The input module is the one through which the computer receives the input, and the output module is the one through which the computer displays or produces its output to the real world. And then there will be a memory module. Whatever the input the user gives, it first enters into the memory module, and then there will be a processor. This processor contains two things. It contains arithmetic logic unit and a control unit. The arithmetic and logic unit performs arithmetic and logical operations. The typical arithmetic operations are addition, subtraction, multiplication, and division. And logical operations are AND, OR, NOT, XOR, all those things. Okay, so these operations are performed by the arithmetic and logical unit. And when which operation should be performed, that will be that decision will be taken by the control unit. So basically, the control unit is the one which coordinates. The control unit is the one which coordinates between the IO unit, memory unit, and arithmetic logic unit. Okay, and the control unit provides signals like when what operation is to be performed. Right? But control unit itself is a part of the CPU. Okay, fine. So, so if you take a typical program, a program is a list of instructions for performing a certain task. And normally the program is stored in the main memory. Okay, that is whenever the program is under execution, it will be in the main memory. And from the main memory, the processor will fetch it. The processor will fetch instruction by instruction from the main memory. That is, the main memory may contain the entire list of the program. From that, it will fetch the first instruction and then it will execute. Then it will fetch the next instruction and then it will execute. Okay, right? Sometimes sometimes some instructions may include data also. Okay, so if there is a data associated with an instruction, then the processor should also fetch that necessary data. Then only the instruction can be executed. Okay, and and how what is the data? See, data are typically the input that we give to the computer, that is called as data. So data can be numbers or encoded characters, and these are typically used as operands. Operands are nothing but inputs or value to a variable, that is called as operand. So if you have a variable a, and then you can then say if a is equal to 10, then a is the operand. A is the operand because it contains some value, so it is an operand. Okay. So data can be either number or encoded characters which can be used as operands. And the computer hardware is nothing but a digital circuit, and there will be two states for these digital circuits. These are on and off. The on is called as 1 and the off state is called as 0. And in a computer, in a typical computer, numbers are, sorry, in a typical computer, numbers are represented uh, numbers are represented in binary notation. Normally we represent number in binary form. Okay? Or occasionally we may use BCD, binary coded decimal. Generally the numbers are represented in a computer in binary notation. Occasionally the BCD notation can be used. Whereas the alphanumeric characters are expressed in binary codes, and these binary codes can be either ASCII or EBCDIC. Okay? ASCII stands for American Standard Code for Information Interchange, and EBCDIC stands for Extended Binary Coded Decimal Information Interchange. Okay. So the alphanumeric characters are expressed either in ASCII or in EBCDIC codes. Now let us, I have already explained you briefly these functional units. Let us try to understand more in detail. So the input unit is the one through which the computer read the data. And the typical input devices are keyboard, joystick, trackballs, mouses, etc. So the commonly used input device is keyboard and mouse. Through that, whatever the user input, that is, whatever the input that are given by the user, that is read by the computer. And then coming to the memory unit. So the memory unit is used to store the program and the data. Memory unit is used to store the program and the data. And we have two types of memory. One is the primary storage, the other one is the secondary storage. Generally, memory refers to main memory, that is RAM, but we have two types of storage. One is the primary storage and the other one is the secondary storage. So the primary storage refers to the volatile memory, which will, that is the content of the primary storage will be retained only as long as the power is available. The moment the power is removed, the content will be lost in case of the primary memory. Okay, whereas secondary storages are non-volatile in nature, they retain the content in spite of whether the power is there or not. And when a program is being executed, the program will be stored in the memory during the execution. And the time required to access one word from the memory is called as memory access time. Okay? The time required to access one word from the memory is called as memory access time. Time required to access one word from the memory is called as memory access time. And for a RAM, the memory access time will range from few nanoseconds to some hundreds of nanoseconds. Okay, for a RAM, random access memory, the memory access time ranges from few nanoseconds to some hundred of nanoseconds. Okay, the RAM itself, the hierarchy of RAM, there may be 3 or 4 levels of RAM. Okay, in a typical computer, there may be 3 or 4 levels of RAM, and how these 3 or 4 levels of RAM differs in the sense they may differ in speed and size. Okay, the smallest and the fastest RAM unit, the RAM which is smallest and which is faster, that is called as cache. Okay, the RAM memory which is small in size and which is faster, that is called as cache. And these cache memories will be tightly coupled with the processor. Tightly coupled with the processor means either they will be kept inside the CPU itself. Say if you say this is the processor, then the cache memory can be placed either, sometimes the cache memory will be placed inside the CPU itself. Such caches we call it as level 1 cache. It will be inside the CPU. Okay, so So we call it as tightly coupled. That is, it is very close to the processor. Or so L1 catch. So this is L1 catch, okay? Or sometimes it may be just outside the processor. In that case, we call it as L2 catch. In that case, it is called as L2 catch, okay? So the RAM which is smaller in size and which is very faster, and such RAMs are called as cache memory, okay? And the RAM which is larger in size and which is slower, that is called as main memory. That is called as main memory, okay? So like that we can have multiple levels of cache. There may be level 1, level 2, level 3. So there is no limit on that. So depending on the type of the computer, there may be different levels of cache. The RAM which is largest and the slowest is called as the main memory, okay? And the secondary storage devices are hard disk, magnetic tapes, optical disks. All these are secondary storage devices which are non-volatile in nature, and they have huge capacity, and they are used to store the data when the power is not available. Fine. And the arithmetic and logical unit are used to perform the arithmetic and logical operation. But before performing the operation, the operands should be brought into the processor. Okay, so first the processor will fetch the respective operands, and those operands will be stored in the registers, and then the appropriate operation will be performed by the ALU, arithmetic and logical unit. And the output unit, once the arithmetic logical unit performs the operation, it means the job is done. And these processed results should be sent to the outside world, and that is done through the output unit. So the typical output units are monitor and printer. So through that, the output reaches the end user. And then we have a control unit which coordinates between all other units. That is, the control unit is the one which coordinates between the memory, arithmetic logical unit, and IO unit. And also it generates appropriate timing signal when any action should take place. Action in the sense here read and write. So I say this ALU, if an arithmetic logic unit want to perform some operation, then what should happen? The operand should be brought into the processor, then only it can perform the operation, okay? So it means that operand should be read. So when which operand should be read, that signal will be generated by the control unit. Similarly, when the arithmetic logic unit finished the task, the output should be sent to the main memory. So that means write to the main memory, then write signal will be generated by the control unit at that point of time. So that is the job of the control unit, okay? Fine. So this is about the functional units of a computer. The next topic we'll be discussing is basic operational concepts. So we'll be discussing this by using some, what you call, some assembly language instructions. So let us consider this instruction. It is add LOCA comma RO. Okay, where RO is a register. Sorry, R0. This is not RO, R0. R0 is a name of a register. So this register contains some value. So that value should be added with LOCA. But LOCA refers to some memory location. Okay, LOCA refers to some memory location. So in memory, some location is named as LOCA. Maybe this location, let us assume, it is named as LOCA. So this memory will have some address. This memory will have some address. Say its address is 5000. Say its address is 5000. Then it means that this instruction, what it says in the sense, first fetch the value from the location LOCA, whatever the value in the location LOCA. Say if it is 25, fetch this value from LOCA. Then add that with the value of RO, R0. If R0 contains 15, let us assume R0 contains 15, then add this 15 with whatever the value available in the location LOCA, that is 25. So 25 plus 15 is 40, and finally store the result in RO. Okay, so RO is a register, it's a CPU register. It's a register which is present inside the CPU. So this RO initially it contains 15, but after executing this instruction, what it will do, it will it will it will fetch this instruction will fetch the value at location LOCA, that is 25, that will be added with 15. So 25 plus 15 will be 40. So finally RO will be updated to 40. So this is after executing the instruction. So let me call it as AE, that is after execution, this will become RO will become 40. But before execution, say let me call it as BE, before the instruction is executed, this particular location RO, this particular location RO, uh, it will have the value 15. It will have the value 15. But after execution, it will be 40 because the LOCA value is added with RO and the result is stored in RO. Okay, right? So this instruction, it includes several steps. It includes 4 steps. What are they? First, there is a instruction fetch. First, this instruction should be fetched from the memory to the processor. So where this instruction will be there initially, it will be in the memory. So first, so this instruction it will be initially stored in the memory. Okay. So whatever the instruction, add so and so. Okay. I'm not writing the full instruction, but understand it's this instruction. Okay. So first the instruction should be fetched from the memory to the CPU. So that is the first job. So this instruction will be first brought into the processor. Then Then what is the instruction? Add LOCA, comma R0. It contains 2 things. LOCA is a memory. It's not an ordinary variable or a register. So the operand for LOCA, that is the operand is nothing but the value. The value associated with LOCA should be fetched. That is the second job. Fetch that. What is that? That is 25. Okay. Then the fetched value will be added with R0. What is the value of R0? 15. Add that. That is the third step. Then store the result in R0. Okay, that's the fourth step. So this simple single instruction actually it contains 4 steps, right? So that is what is being explained here. Okay. But in modern computers, so here you can see this single instruction, it actually combines 2 things. Memory load, the first loading data from the memory. This is you are loading, that is you are loading the data operand at LOCA is fetched means the data from some memory location is loaded. Okay. And and then we are performing the arithmetic operation. That is we are adding that fetched data with R0. So memory load and arithmetic operation are combined in single instruction here. Are you getting the point? Memory load, because as it is a memory location, the value for this, the value corresponding to LOCA should be loaded from the memory. So memory load and arithmetic operation, that is adding the fetched value with R0, both were merged in a single instruction. But in modern computers, this won't happen like that. In modern computers, memory access and arithmetic operations are separated. In modern computers, memory access and arithmetic operations are separated. Okay. So in a modern computer, it will be, instead of doing like this, it will be done like this. First, there will be an instruction called load LOCA, R1. So this what it will do in the sense, it will load the value corresponding to LOCA to the register R1. Okay. So as already discussed, let us assume this particular location in the memory. Let us call this as LOCA. Let us call this as LOCA. So if this location contains the value 25, then load LOCA, R1. What it will do in the sense, it will load the value that is available in the location LOCA to R1. So now R1 will contain the value 25. Now R1 will contain the value 25. Okay. And R0, already we are assuming that R0 is holding the value 15. R0 is holding the value 15. Okay. R0 is holding the value 15. And then we are saying add R1, R0. Now R1 and R0 will be added and the result will be stored in R0. Okay. So whatever the previous value of R0, that will be updated. So previously R0 is 15, but after executing this instruction, R0 will become 40. Okay. R0 will become 40. So this is how it works. Okay. So in a modern computer, this memory fetch and arithmetic operations are separated into 2 different instructions, something like this. Okay. And normal flow of execution may be disturbed by interrupts. I think this you are already aware, because generally the program executes in one flow, and that can be disturbed by interrupt. So interrupt are something like high priority task, and when some interrupt comes to the CPU, then the processor will halt the current job, and it will service the interrupt service routine. Okay, fine. So this particular diagram, it actually gives us more understanding about the basic operational concepts. So this is memory, the main memory, which contains the program. Okay. So let us assume that the main memory contains some program, right? Say the program contains few lines, maybe 10 or 20 or 30 lines, whatever it may be. Okay. Other than that, what are the other units here? Let us see. Okay. So this is nothing but the CPU. This entire unit is nothing but the CPU processor. Okay. So the processor, if you see, it contains MEAR, which stands for memory address register. It's just a register, but it contains the address of the memory. It contains some address of main memory, from where the data should be read, or to where the data should be written. Are you getting? So this memory address register is a register. So typically this register will contain some address. Okay. So so what address? For example, if it contains the address 4000. Okay, if it contains address 4000, and and then it means that whether either you have to write some value to the location, either you have to write some value to the location 4000, or you have to read some value from the location 4000. That depends on the control signal. If the control signal is read, if the control signal is read and the memory address register contains 4000, then it means that read the value from the address 4000 and store it in MDR. MDR is memory data register. So whatever the data available in the location 4000, say in the memory, let us assume this is 4000. So then what will happen in the sense, the data available, data or instruction or whatever it may be, whatever is available in the location 4000, it will be moved into MDR, which is memory data register. Okay. It is under which circumstances, if MEAR contains 4000 and the control signal is read. Okay. Let us assume MEAR contains 5000. If MEAR contains 5000 and if control signal is right, not read, then it means that whatever the current value in the data register, say currently data register contains some information, say it contains the value 101, binary 101. Okay, then it means that write the content of the data register to the location 500. So let us assume this location is 500. Let us assume this location is 500. So then what it says in the sense, whatever the content available in the MDR, memory data register, write that to this location in the memory 500. Okay. So that is the job of memory address register, memory data register, and the control unit is the one which generate appropriate control signal, like what operation is to be performed. I think it's clear. Okay. Fine. And then PC, program counter. This you know already. Program counter is the one which contains the address of the next instruction to be executed. Program counter is the one which contains the address of the next instruction to be executed. When the program is first loaded, into the main memory, and if no instructions were currently executed, then the program counter will point to the first instruction. Okay, so if this is the program, then the program counter will point to the first instruction. Okay, then what will happen? Then the processor will fetch the first instruction. And the first instruction will be stored in the IR register. Okay, so the IR register is nothing but the instruction register. IR register is nothing but the instruction register which contains the current instruction that is being executed. Okay, so initially it will have the first instruction, next it will have the second instruction, then third, like that, whichever the instruction. So the entire program will not be moved into the processor, rather instruction by instruction it will be moved. Okay, so when the program counter is pointing to the first instruction, first that instruction will be moved to IR register. Okay, then after loading it to IR register, the appropriate operation will be performed with the help of arithmetic and logic unit. Okay, the appropriate operation will be performed with the help of arithmetic and logic unit. So after fetching the instruction, the processor will decode the instruction and then it will understand what operation is to be performed. If it is add, then the appropriate operands will be fetched and it will be stored in the appropriate registers, and then the operation will be carried on by the ALU, arithmetic and logic unit. Okay, so once the first instruction is executed, then PC will update to the second instruction. Then the second instruction will be moved to instruction register. Okay, so the instruction register will always contain the current instruction to be executed. And then the processor will decode the instruction, will understand, and then the appropriate operation will be performed. Okay, and these are the R0 to Rn minus 1. These are the general purpose register that is available in a CPU. So the registers are normally 16 bits or 32-bit registers. So the registers are nothing but these are some memory which is available inside the processor, and the register is the one which the processor can access very quickly. Okay, so the content in the registers are available within the processor itself, so it can access in no time, right? So this diagram is very crucial. So you should know what is MAR, MDR, what is control unit, what control unit does, and what is IR, because all these things will be using throughout the course. So MAR contains the address, memory address register. It contains the address of the memory to where you want to perform the read operation or the write operation. The MDR contains the data, whether the data, sometimes the data will be written to the memory, or sometimes the data may be read from the memory. And the control unit will generate the appropriate control signal, like whether the read operation to be done or write operation is to be done. And IR register will hold the current instruction to be executed. And PC contains the address of the next instruction to be executed. And R0 to Rn minus 1, all these are the general purpose registers. Okay, so let us stop here for today's session. So what we have discussed is, we have discussed the basic computer architecture, uh, the functional units of the computer, the different types of computers, and also we have discussed the basic operational concepts with some assembly language instructions. Fine.